This video is over lessons 23 and 24. Lesson 23 is ratio and rates. Lesson 24 is adding and subtracting fractions that have common denominators. Take a moment to copy this into your notes. Pause the video if you need to. Moving on in 3, 2, 1. A ratio is a way of describing the relationship between two numbers. For example, let's say that there was a class where there were 12 boys and 8 girls. We could say that the boy-girl ratio was 12 to 8. So notice here that the name of the ratio, the boy-to-girl ratio, tells me what each of these numbers means. There are no units in the ratio. So the fact that boy comes first here means that the first number here must be boys. And that girl comes second. The second number must be the number of girls. There are 3 different ways to write a ratio. We can write it as we've written it in words, or we can write it symbolically. We can write it with a colon. We can also write it as a fraction. Now, something to keep in mind is that since a ratio is a way of describing the relationship between two numbers, even if I end up with a fraction like 12 over 8, if I were to make this a mixed number, it'd be 1 and 4/8. Well, but now I've got 1, 2, 3 numbers. So we will never change ratios into mixed numbers. This is one time where it is okay to actually leave your fraction as an improper fraction. Now, with that being said, since it is a fraction, or can be written as a fraction, that means that we can also reduce our ratios. So, if I divide both of those by 4, I end up with 3 over 2, which means that this would also be a 3 to 2 ratio, or 3 to 2. Notice that no matter how it's written, we always say it like this. This is a 3 to 2 ratio. And so, you need to remember to reduce your ratios. Order is very important when it comes to ratios. If I change the order here and make this a girl-boy ratio, then the first number represented should have to do with girls. So since up here girls came second and the reduced number was a 2, when girls comes first, my reduced ratio will start with a 2. And then obviously the boys' reduced number is a 3. So the girl to boy ratio would be 2 to 3. And what this means is that for every 2 girls, there are 3 boys. So if I have 4 groups of 2 girls, in other words, 8 girls, that means I'll have 4 groups of 3 boys, in other words, 12 boys. And this could be applied to other situations. If I find out later on in a different classroom I have the same ratio of girls to boys, but I find out I have 10 girls, well, that's 5 groups of 2, so then I must have 5 groups of 3 boys, or 15 boys, and on and on and on. Moving on in 3, 2, 1. A rate is a ratio between two numbers with units. And they use the words per, for every, and each. So as you're reading through a story problem, if you see any of these situations, you're probably dealing with a rate. For example, 50 miles per hour means that for every 50 miles traveled, it will take 1 hour. And now we haven't written a 1 in there, but it is implied. This also means for every 1 hour traveled, we should be going 50 miles. And we can use this in story problems as a unit multiplier. So for example, let's say we travel for 8 hours, and I want to know how far we've gone. Well, we take 8 hours and put it over 1, and then multiply that by the rate. So 50 miles for every 1 hour means I'm either putting 50 miles on top and 1 hour on bottom, or 1 hour on top and 50 miles on bottom. So in this case, since we have hours on top, I'm going to want my 1 hour on bottom. So 1 hour goes on bottom, 50 miles goes on top, and we do this so that the hours on top will cancel the hours on bottom. And so now we multiply. On the bottom I have 1 times 1, which means my answer is going to be a whole number. On top I have 8 times 50, which is like 8 times 5, which is 40, with an extra 0. So 400. The units that are left over are miles. So at 50 miles an hour, 8 hours of traveling will result in traveling 400 miles. Also, we could use this to figure out how long we've been traveling if we go the other way. So, for example, let's say that we've traveled 600 miles. I'll take that starting amount, turn it into a fraction, so put it over 1. And again, we're going to multiply. And remember that it's either going to be 50 miles on top with 1 hour on bottom, or 1 hour on top with 50 miles on bottom. So this time, I have miles up here already, which means I'm going to want my 50 miles down there. Which means my 1 hour goes on top. And we do this so that the miles here and the miles there, one on top and one on bottom, will cancel each other out. Now I've got 600 times 1 on top and 1 times 50 on bottom. So before I multiply, I'm going to do some reducing. The obvious reducing I can do here is dividing both of those by 10. So if we start with that, this becomes a 5, this becomes a 60. And now 5 obviously goes into 60, and 5 goes into itself, so we can reduce these again. 5 goes into itself once, 5 goes into 60 12 times. And now we have a much easier problem. All 1's on bottom now mean that this is a whole number. So up top, I've just got 12 times 1 hour, which means we've been traveling for 12 hours. Moving on in 3, 2, 1. Remember that in fractions, the numerator tells us how many pieces we have. And when it comes to adding and subtracting, we should think of the denominator as the size. And because of this, when we're adding and subtracting fractions, we need to have a common denominator. Our pieces, however many pieces we have to have the same size, so that when we put them together, we know what size to describe them collectively. So, if I'm adding fractions, let's say 2/5 plus 3/5, this means I have 2 pieces plus 3 pieces. These pieces are fifths, and these pieces are fifths. Well, 2 pieces plus 3 pieces gives me 5 pieces. What size are they? Well, they were fifths here and they were fifths here. When you put things together, they don't change their size, and so the denominator stays the same. Don't forget to simplify your fractions once you're done. So this is an improper fraction. So we do a little bit of division. 5 divided by 5 gives me 1. If we had 2/7 plus 4/7, well, 2 pieces plus 4 pieces gives me 6 pieces. If they were sevenths here and they were sevenths here, just because we put them together doesn't mean the size changes. So they're still sevenths. It's a normal fraction, so I'm done. And we'll go ahead and do one more example. This time, let's do 5/8 plus 7/8. So 5 pieces plus 7 pieces gives me a total of 12 pieces. They were 8s here, they were 8s here, so over here, they're still going to be 8s. Now we need to simplify this final fraction. If you look at it closely, you can see that this is improper. The 12 is larger than the 8. Also, we can see that this can be reduced. Both of these can be divided by 4. It doesn't matter what order you simplify it in, just so long as you do both things. So I personally find it a little bit easier if you change it to a mixed number first. So 8 goes into 12 once. How many pieces are left over? Well, if you subtract 12 minus 8, so 8 of these pieces were taken away to make this 1, that leaves 4 left behind. What size were they? They were 8s over here, so that means the 4 pieces left over are still the same size. Now we reduce, divide the fraction by 4/4, and we get 1/2. So my answer is 1.5. Notice that the 1 from here carried over here. Moving on in 3, 2, 1. Your book will only be requiring you to add and subtract fractions with common denominators. But as a reminder, let's review what to do when we have a denominator that is not the same. So, for example, let's say we had 2/3 plus 5/8. First of all, 2 and 5 makes 7. 3 and 8 makes 11. Don't do that. Remember what we just talked about. These are thirds, these are eighths. They are not the same size. Just because we put these pieces together does not mean that they're all going to change size to become 11ths. So this is a big no. The proper way to do this problem would be to set it up vertically. And from here, I need to change these to have the same denominator. Well, I want to change them without changing their amounts. So remember, we use forms of 1, because when you multiply by 1, the amount doesn't change. So I'm going to multiply each of these by a form of 1, so that in the end, my denominators will be the same. Well, using multiplication, 8 and 3, if I multiply 3 times something and 8 times something, I can turn them both into 24. And that'll be 3 times 8. So this form of 1 must be 8 over 8. Finish off the multiplication. 2 times 8 is 16. On the bottom there, 8 times 3 is 24. So this form of 1 must be 3 over 3. Finish off the multiplication. 5 times 3 gives me 15. So my new addition problem is 16 24ths plus 15 24ths. Add them up. 16 plus 15 is 31. What size were they? Well, these are 24ths, these are 24ths, which means altogether they're still 24ths. This is an improper fraction, so we need to simplify. 24 pieces will make one whole, so if I take 24 of these, I get one whole. Well, taking 24 away will leave 7 behind, and they're still 24ths. This video ends in 3, 2, 1.